So question number 36. 36 states a free fall parachutist falls at a constant speed. Constant speed means it initially it is moving with a constant velocity. He then opens his parachute. When the parachutist opens uh, his parachute, this is the second part. Like the initially its velocity is constant. This is first part of the graph. Second part of the graph is opens the parachute. When it opens the parachute, its surface area increases and resistance increases, its velocity decreases. Now we have third part. It continues to fall to the earth at a lower constant speed. So again the third portion is again a constant speed. Here is a constant speed. So let's match our graph, given graph. Okay, so let's start with the option D. Here it states the distance, it's a distance time graph. So okay, it looks like this graph tells us that the object, like it's like the gradient, if you find out the gradient of this graph, okay, if we calculate the gradient of this graph, distance time graph, the gradient of distance time graph is actually speed. So it tells us that the object is moving with uniform or constant kind of speed here. Then after this, the distance is not changing. It means object is in state of rest. You can see time is passing on, going in onward direction. The time is increasing, but the distance is not changing. Distance not changing means object is in state of rest. So when a parachutist is falling, it would be in state of motion. So that's incorrect. So let's move to C part. In case of C part, it says, look, the object is in state of rest. Distance is not changing. So it is also incorrect. Let's move to option A. Here again, the distance is not changing. Oh, sorry. Distance is not changing. Distance is fixed with the passage of time. It means object is in state of rest. So for a short interval of time, the object, like for a moment, the distance decreased, then again object is in state of rest. So we are left with only one option that is correct, that would be correct option. But why it's correct? Let's see. The question says a parachute falls at a constant speed. Okay, so let's consider the first part. If we calculate the gradient of this portion, of the graph, it will give us a uniform speed. Okay, then opens the parachute. When parachute is opened, the distance, the speed decreases, but the object would be continuously in state of motion, it will continuously travel some distance, so the distance will increase. So you can see at this point might be a jerk time for a short interval, the parachute would be opened, and if you just carry on the previous velocity like this, previous graph which is going like this, so the original graph would be something like this, but after this interval the graph has changed its shape. Instead of going in this way, the graph has changed like this. It means its gradient is decreased. So this, for the gradient of distance time graph is actually speed, it means speed is decreased. So this is actually given here, somewhere here, the blue one. Earth at a lower constant speed. So this speed, the blue one is high speed and the red one is lower speed. That's why it is quite similar to the given option. So let's move to number 36. So 37 says the graph shows the speed of a runner during a race. Okay, it's a speed time graph. What is the distance traveled by a runner during the race? Actually, we know that the area under the graph, speed time graph, is actually the distance traveled by the object. So we are going to divide this graph into various parts. So this one is one part, this is the second part, and this would be the third part. So this one is a triangle, this is rectangle, and this one is trapezium. So here we would apply the area of triangle. Area of triangle is 1 by 2 sum base into height. Base is 3 and height is 5. So this is the area number 1, which is equal to 7.5. Okay, second is A2, which is the area of rectangle. So rectangle actually starts from here, which is 3 till 14. So 14 minus 3 is 11. 14 minus 3 is 11. And height is 5, which is equal to 55. Okay, the next is trapezium. So trapezium is sum of parallel sides. This one is one side and this one is second side. So this side is 5 and this side is 10. So 10 plus 5, and the connecting line is 2. So height is 2. 1 by 2 sum of parallel side is 10 plus 5 multiplied height. Height is 2, so 2 is cancelled with 2, we have 15. Oh, I think I made a little mistake. See, the difference is 2 4, like there is a 2 difference, so it means it wouldn't be 2, it is 4. So 4 5s are 20, it would be 10. Make a correction here. Okay, so it is 4. It is 14, so it would be not 11, it would be 10. 10 times 5 is 50. So area of rectangle is 50. I think so rest of the things are correct. So now total area is, so this area is actually area of triangle is 10, area of rectangle is 50, and area of trapezium is 15. So okay, so total area is 15 plus 65, 50 is 65, 65 plus 10 is 75. So total area is 75, and the correct option is this one. Question number 38 looks very simple type of question. It says, which velocity time graph shows that the object is moving with non-uniform acceleration? So A is a uniform acceleration, looks like there. If we calculate the gradient of this graph, it would be a uniform acceleration. This is uniform deceleration, and in case of D, there is no acceleration. Zero acceleration is also a uniform acceleration. And look at the C part. If we consider this is the starting point, and this first point, this is our, suppose this is the first point, then during this period the acceleration would be different. Okay, if we consider this point and this point, the acceleration would be different. If we consider this point and this point, the acceleration would be different, and for the onward points, the acceleration for each point would be different. So this is actually the graph which represents a non-uniform acceleration. Okay, question number 39. The graph shows the graph shows the speed of a car as it moves from rest. Okay, during what is the average speed of the car during the first 3 seconds? So okay, average speed is actually total distance over total time. So average speed is total distance over total time. So for total distance, like the diagram is actually like area under the graph is actually area of this triangle. So for this triangle, the area of this triangle would be the total area. So it's a right angle triangle, so we can calculate area of triangle. Simply 1 by 2 base into height. Base is 3, height is 12, so it would be 36 over 2, which is 18. So the distance is 18. Now the average velocity is, total distance is 18 and total time taken is 3, so it would be 6. So the correct option is 6, and this is the correct option. So number 40, in number 40 it states a skier is traveling downhill, the downhill, skier is traveling downhill, the acceleration on a hard snow is 4 meter per second. Okay, this is the hard snow area where the speed is 4, and on snow, on soft snow it is 2 meter per second. Soft snow is 2 meter per second. Which graph shows the motion of the skier when moving from hard snow to soft snow? It means the skier is moving from hard to softer one. So it means initially its acceleration would be large, it means its velocity, change in velocity would be large, and then its acceleration is 2 meter per second square. It means after that its change in velocity would be small. Okay, so let's see the graph one by one. See A looks incorrect because, see why? Because see, it started from 20 and remains 20 for a long period of time, suppose for 5 seconds. So the speed is constant. Constant speed means no acceleration, so it means it's incorrect option. Here you can see there is again there is a constant velocity, so constant velocity means acceleration does not exist. So let's move to part B. In part B you can see during the first part of the graph till here the velocity is increasing, it means acceleration is produced. After this the velocity is continuously decreasing, but the statement says when the skier will move from hard to softer one, its change in acceleration would be 2 meter per second, and it would be fixed. Okay, and it is positive, not negative, so that's why it looks inconsistent with the statement. Okay, now look at the C and D. So let's compare them. C states that like this is the first portion of the graph and this is the second portion of the graph. So if we compare these two portions with each other, it states that the gradient for this portion is larger than the gradient of this portion. It means the acceleration for this portion is larger than the acceleration for this portion, which is quite similar to the given option because the gradient of velocity time graph is acceleration. Okay, let's see the next one. In next one it says the gradient during this portion is smaller than the gradient for this portion. It means the acceleration during this period of time is smaller than the later one, so it is inconsistent with the given statement. The diagram which represents the moon in its orbit around the earth. Which arrow represents the direction of resultant force acting on the moon at the instant shown? Okay, this might be centripetal force which is actually attracting an object towards the central point, and this might be the centrifugal force which is in outward direction. I don't know this one. This might be the direction of velocity, but it looks that the object is following this path. It means the B is actually the resultant one, which keeps it in along a circular path. So this might be the resultant force. Okay. Now let's move to 42. A car is brought to rest in 5 seconds from a speed of 10 seconds. So we know that the rest means starting velocity is 0 or initial velocity is 0 to a speed of 10. It means final velocity is 10. In 5 seconds, it means time is 5 seconds. So we can write it like this: final minus initial. Oh, okay. Final is 0 minus initial divided by 5 seconds, which is equal to minus 2. So the average acceleration of the car is 2 or minus 2. So actually the writer is not bothering with science, so our correct option is this one.